Ordinary cooking oils turn cloudy and solidify in the fridge, ruining your cold salad dressings. To keep cold dressings completely clear and liquid, producers use a process called winterization. How do labs verify this? They take a 100-milliliter sample of the salad oil to see if it survives. To ensure strict isolation, the bottle is sealed completely shut with paraffin wax. Then it's plunged into a cross-section bucket fully submerged in cracked ice and water. The oil isn't just dipped. It must survive in this freezing bath for exactly 5.5 hours. If the oil was properly winterized, it passes the test. The bottle is pulled out, and the oil inside remains perfectly clear and effortlessly pourable. But if the sample emerges cloudy or solidifies unevenly, it means it was improperly processed or illegally adulterated with cheaper fats. And that crystal clear passing sample, it guarantees your dressing stays perfectly smooth, even straight from the fridge. That pristine bottle of coconut oil in your kitchen might actually be a fake. Cheap filler oils blend into it perfectly at room temperature, making them completely invisible on the shelf. To expose them, just put that suspect bottle in the fridge, not the freezer, for 30 minutes. If it's pure, it reacts to the cold by completely solidifying into a uniform white block. But what happens if it's secretly spiked with a cheaper substitute? Those filler oils have a completely different freezing point. As the real coconut oil hardens, the cheap filler refuses to freeze. It gets forced out of the solid matrix, pooling at the top as a distinct liquid layer. So when you finally pull that test bottle out of the cold, if it emerges with a golden puddle of liquid floating over the white solid, you have just caught a fake. TOCP is a highly toxic chemical secretly contaminating some cooking oils. Consuming this hidden danger is a massive health risk, but you can expose it at home without a laboratory. To start, take a 2-milliliter sample of your questionable cooking oil and isolate it inside a clear testing container. Now, drop a small piece of solid yellow butter directly into the sample. At first, nothing happens. Before the chemical reaction begins, a pure sample and a contaminated sample look perfectly identical. But watch closely for the definitive warning sign. The contaminated cooking oil reacts with the butter and immediately turns a harsh, bright red. By contrast, look at the pure, uncontaminated oil in the second vial. It maintains its original golden color perfectly. So what about that questionable sample you just tested from your own kitchen? If that mixture turns red, you've just exposed toxic TOCP. Throw the bottle away.